In the previous video about limiting reagents or limiting reactants, we've known that limiting reactant is the reactant on the left side of the chemical equation that limits the amount of products that will be produced because these are in limited amounts. On the other hand, the reactant that occurs in excess are what we call the excess reactants or excess reagents. We've known the concept about limiting reactants based on the analogy of the burger ingredients. And in this case, if you have 3 pates, 4 buns, there are 6 cheeses, and there are 7 tomatoes, we know that the one that limits the number of burgers that will be produced will be the pates because there are 3 of them. So the lesser amount of pates will limit the amount of burgers, which in this case will only produce 3 burgers with complete ingredients, and the rest of the ingredients will be in excess. Same thing with the chemistry shirt and the pants because there are fewer pants. That means you can only have complete pair of shirt and pants, 2, and the one in excess will be the shirt. The pants will limit the amount of your complete attire that you're going to wear because there's just a few of them. So similarly, in a chemical equation, if you are given a certain chemical reaction of amounts, I've pointed this out in the last video, that when you're dealing with a limiting and excess reagents problem, you always have to note that there will always be 2 given, one of each of the reactant. It can be 2 or more. In this case, there are just 2, 1.50 moles of methane gas and 2.50 moles of oxygen gas. So since you are given the two reactants, that means you need to calculate for the amount of products that each of these reactant will produce. So in that case, when you are to convert it to a certain product, always focus on one product. So in this case, in our calculation, it was water. Because you're given already the mole for each of the reactant, that means this can just be as simple as mole to mole conversion, because we're just going to find out how many water and how many water for CH4 and how many water for O2 that will be produced, because it has to be the same unit for them for us to be able to compare the products produced. So in this case, we found out that for 150 moles of CH4, it produces 3 moles of water, and for 2.50 moles of O2, we produce 2.50 moles of water. So we have to look at the lower amount or the lesser amount of common product that will be produced. That's how we figure out what's our limiting reactant. Of course, our limiting reactant is not water, it's a product, so that means it's always the left side, which is O2, because O2 limits the amount of water that will be produced. And so the other reactant, CH4, becomes our excess reactant. What does it mean? That our CH4 is not entirely used up or consumed in the reaction. Not all the 1.50 is consumed in the reaction. There's only a portion of that, and there's always an excess. In the following videos that I'm going to release later on, we will learn how to calculate for the amount of excess reactant that will be unused in the chemical reaction. But for now, let us just know how to determine the limiting and excess reactant in the reaction. And it's safe to note that you cannot accurately assume that if the given is lesser, it's the the limiting reactant. No, it doesn't follow. You have to undergo the conversion for us to be able to accurately determine that that particular reactant will produce the lesser amount of product. So always do not assume, but undergo the computation. So just some points to note and some mistakes to avoid in this particular computation of LR and ER. Points to note: limiting reactant produces the lesser amount of product always. And when you determine the LR and ER, focus your stoichiometric calculation on one product only so that you can compare one product and the same final unit. And then lastly, identify the given and the correct conversion factor that you need to use to be able to come up with the accurate values. Identify always what unit you're given and identify what conversion factor you need to follow so that you can get the accurate value in the end so you can compare. And mistakes to avoid: limiting and excess reactants or reagents identification. Always take note, because these are reagents or reactants. You focus your attention on your given, which are identified to be on the left side of the equation. Then incorrect coefficients use. When you use the mole ratio, always check whether you balance them correctly or not. Then do not mix up your calculations. Remember that it should be uniform calculation when you do LR and ER. If you're doing um, one single product, that means all the other computations should be focusing on that single product alone. If you're using mole ratios, that means you need to be able to identify the correct mole ratios of the substances you're dealing with. If you're doing molar masses, that means you have to correctly input your molar masses values. Then, having different products, that can give you incorrect answers also. So remember that your products have to be the product, one product have to be the same. And when you input the values in the calculator to improve efficiency and accuracy, use your parentheses to group the numerator and then press divide and then another parentheses for all the values in the denominator. Always check whether you input the correct values so that you will avoid committing mistakes in the end. Do not round off, do not chunk the computation so you avoid dropping values. We need to have the most accurate values in the end, so that's why I am suggesting that you do your parentheses function in your calculator. So for this particular, to apply all these points to note and mistakes to avoid in the previous lecture on identifying ER and LR, I want to leave this to you. This problem about methane, the combustion of methane gas producing CO2 and water. I want you to solve this particular problem. You have 12 grams of methane gas and 10 grams of O2 gas. You tell me what's the limiting and excess reactant by providing a very detailed justification of your answer. So I'm gonna expect your answers to be left in the comments below. Tell me also your difficulties in coming up with this particular problem solving. And if as much as possible, improve your efficiency, your speed, and your accuracy when you're doing these calculations. Please feel free to ask your chemistry teacher for more clarifications. So bye for now. This is Madam Narca saying, do not stop learning, relearning, and unlearning. Please like, comment, share, and subscribe to my YouTube channel. Bye-bye. Enjoy learning.